Oh, I hate this word, simple. It makes me fear to appear stupid. Well, gamma naught, gamma n, they are matrices of the form 1 plus an, b, c, 1 plus dn, and gamma naught of n squared. It has the form a, b, c, d, c, n squared. And since it needs to be an isomorphism, I would like to have a similarity transformation such that if we must multiply c by n, then we should have n in the bottom. We should be able to do it to all of n. Now, the one I was thinking of was using d equals something like that. I'll just check that I have the right gamma naught. Yes, I do. The point we should have c multiplied by n, so we should have n in the first row when we do it from the right. Let's see what this gives. And the inverse of this, it has determinant n minus 1. It doesn't really help us now. The first row should be multiplied by n, so we should have n in the top. I say the first column. that has determinant naught, so that is totally silly. You see, I'm so nervous that I really can't find the simple isomorphism. One could use n minus 1, then we have to, it has determinant unity, so the inverse and minus 1 minus n, n minus n plus 1, n minus 1 plus n, naught, and naught. So that works. So I did get something a squared, n squared, as I anticipated, but then I got some nonsense. This means that I'm thinking in a far too complicated way. Time for a break and coffee. While the coffee is brewing, emptied the dishwasher and put the coffee over. Let's try with a very, very simple guy. And see what happens when we apply that. And there should have been an n here as well. That was really dumb. Well, this is a similarity transformation, so it's a homomorphism. So let's see what the image is of it. And we multiply the 2 to the right first. Oops, the first one so maybe we should have n up here, so that Cn will be multiplied by. Let's do that. And Cn squared and this gives bn and 1 plus dn. So this just multiplies the first column with n, and then this should divide the first column, the first row by n, which is what it does. All right, this gives, of course, it's an isomorphism onto a subgroup of gamma n2, and it's the subgroup where the first, or the diagonal elements lie in I don't know, in the side class of 1 modulo n. Not even it's equivalent to 1 modulo n. The coffee has finished. I have a nice cookie here with chocolate in it, but I'll just put it aside and wait and do with the coffee until we're finished. When we are up here, there can be any a point D in phi of n squared. And this is a little weird. What is that? It seems to be n times phi of n. So we have n phi of n possibilities, and AD equals 1 modulo n. There should be n possibilities within n square. So that means it has index phi of n. So up to n square, we have 1, 1 plus n, etc., up to 1 plus n minus 1, n. Yes, that's right. So this was interesting. I didn't know this. All right, so the difficult thing is here was that we had to think out of the box. I was trying to find a similarity transformation with a matrix lying in gamma. But we had to use a rational guy instead. So we had to think outside the box a little, and that made it very hard for me.